Hi, this is Mrs. Doris, and this is Lesson 8-1 entitled Adding and Subtracting Polynomials. Our objective in this lesson is that you will classify, add, and subtract polynomials. And the reason that we are working in this chapter in algebra is that all the facts of arithmetic and algebra follow from certain properties. And a single quantity can be represented by many different expressions. All right, so we've got a lot of definitions in this chapter. First of all, a monomial is a number, a variable, or the product of a number and one or more variables. Some examples of monomials. A number can be as simple as 5. A variable, how about just x? Or the product of a number and one or more variables. So let's make it look something like this. Negative 12x to the second, y to the third. All right, so we have 3 examples. One of just a number, the second one is a variable, and the third one is the product of a number and more than one variable. All right, now the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. All right, and some examples. Let's use our examples up above. The degree of 5 would be 0. And that's because the degree of a non-zero constant is 0. And the reason, all right, I apologize for the interruption. The reason that the degree of 5 is 0 is that 5 could be written as 5 times x to the 0 power. And as you know from the last chapter, x to the 0 power is equal to 1. So 5 times 1 is simply 5. And that's the same as our example up here. And so the exponent has a 0 in it, and that's why its degree is 0. All right, in our next example, the degree of x is 1 because of the exponent 1. And in our last example, what we do is we take 2 plus the 3, and its degree then would be 5. All right? Now, 0 is an interesting number in that we don't say it has a 0 degree, we say it has no degree. And that is different from having a 0 degree. All right, so problem 1, finding the degree of a monomial. What is the degree of each monomial? Well, 8xy, x and y each have an exponent of 1. 1 plus 1 is 2. All right, so it has a degree of 2. In our next example, negative 7y to the 4th z, z has an exponent of 1, and 4 plus 1 would give it a degree of 5. And 11 has a degree of 0, since 11 could be written as 11 times x to the 0 power. All right. Now, to add or subtract monomials, the terms must be like terms. In other words, the variables and the exponents must be exactly the same. For instance, you can add 12x squared y and 3x squared y since they are like terms because they have the same variables and powers. This has x squared y in it and this has x squared y in it. So all you have to do is add the two coefficients, 12 plus the 3, which would give you 15x squared y. Now notice that the variables and their exponents stay exactly the same. They don't change when you're adding or when you're subtracting. In the next example, you cannot add 3x and 12x squared since the terms are not like terms. Notice 3x has a power of 1 to the x and 12x squared has a power of 2. Since they are not the same powers, you cannot combine them. So we would simply have to say 3x plus 12x squared, and that is as simple as we can make it. All right. Now, please note, down at the bottom, don't confuse this with multiplying powers. And let me rewrite this. X times x squared is x cubed because we have x times x, and that gives us x cubed. But we cannot take x and add it to x squared because those are two different powers. And so when it comes to adding and subtracting, they have to be alike in order to combine them. Problem 2, adding and subtracting monomials. What is the sum? Negative 6x to the fourth plus 11x to the fourth. All right, well, notice that we have x to the fourth in each of our terms. So all we have to do is take our coefficients, negative 6 and the plus 11, and combine them and then put x to the fourth after it. So negative 6 plus 11 is 5. X to the fourth would be our simplified answer. What is the difference? 2x squared y to the fourth minus 7x squared y to the fourth. Well, again, notice that we have an x squared y to the fourth in each term. So all we do is combine our two coefficients, 2 minus the 7, and then we put our x squared y to the fourth after it. So 2 minus 7 is negative 5, and so I have negative 5x squared y to the fourth. All right, some more definitions. A polynomial is defined as a monomial or the sum of monomials. All right, so for instance, a polynomial can just be a monomial, like our 5 or like our x. Or it can be the sum of monomials, like, let's take an example, 5 plus x, or x squared plus 2x minus 7 is also a polynomial. Now you may say, well, I see a minus sign in there, and that's not a sum. Well, remember, we can change that minus to adding the opposite, and now we have an equivalent expression, x squared plus 2x plus negative 7. And that is also a polynomial, even if there's a minus sign in there. All right, our next term is standard form of a polynomial. And a standard form of a polynomial is the terms are written in descending order according to degree, the degree of each term. All right, so let's take an example. I'm going to make one up, and we'll write it in standard form as we write it. You want to look for the term that has the highest exponent, or the highest degree. So, for instance, 5x to the third would be written first before 3x squared, before 10x, before minus 7. And the reason why this is in descending order, don't look at the coefficients. It doesn't matter what the coefficient is. Only look at the exponent. 3 is the highest exponent. 2 is the next highest. 10x has an exponent of 1, which would be the next highest. And any constant has a degree of 0. So every constant is written as the final term. This is what is known as standard form, and all your answers will be given in this form. Okay, the degree of a polynomial is the highest degree of a single term. Okay, so for instance, in our example, and I'll just write it again down here. In the example that's right up above, 5x cubed plus 3x squared plus 10x minus 7, the degree of the polynomial is 3. And that is because 3 is the highest degree of any single term in that polynomial. So there's no adding together of the exponents to find the degree of a polynomial, unless you would have more than one variable in the term. Okay, now we have some more vocabulary, and we're going to just put it into a chart. We're going to first classify polynomials based upon their degree. So 11 has a degree of 0, and when it has a degree of 0, that is known as a constant. Constant is a very specific term for a monomial that is a number. All right, in the next one we have a degree of 1, and so that makes it first degree, and the name is linear. Hopefully this expression 4x minus 3 reminds you of y equals mx plus b, which is the equation of a line. All right, in our next example, we have a degree of 2. When you have a degree of 2, that's called a quadratic polynomial. All right, and quadratic is what we're going to be dealing a lot with in this chapter. In the next example, we have 3 as our degree, and that makes it a cubic polynomial. And the last example, we have a degree of 4, and that's called quartic. Now, anything beyond that, we would simply say it's a polynomial with a degree of 5, or a polynomial with a degree of 6, or whatever it might be. All right, now, the other way that we have of classifying is according to the number of terms. So let me erase this so that I'm going to start circling again. Here we have one term. When it's one term, it is a monomial. All right. In our next example, we have 4x and we have minus 3. That is two terms, and we call that a binomial. You might think of the word bicycle with two wheels on it. Our next polynomial has 3x squared, 2x, and 7 as a term. So it has three terms, and that is called a trinomial, as in tricycle, that has three wheels. Our next one simply is one term, 8x cubed, which makes it a monomial again. And the last one, 9x to the fourth, is one term, 2x is another term. So we have two terms, and that makes it a binomial. Now, please note at the bottom, any polynomial that has more than three terms is simply called a polynomial. So we don't have interesting names for polynomials that have more than three terms. All right, so let's classify. It says write 2x minus 3 plus 8x squared in standard form. All right, so for standard form, I'm looking for the highest degree possible, and that is 8x squared. All right, then I'm looking for the next highest degree, which would be the 2x, since it has a degree of 1, and so it'd be plus 2x. And then finally, I have a constant, minus 3, and the constant always comes at the end because it has a degree of 0. Now, next question, what is the name of the polynomial based on its degree? All right, well, it has a degree of 2, so it is quadratic. All right, and what is the name of the polynomial based on its number of terms? Well, notice we have one term, two terms, three terms, so it's a trinomial. All right, in problem 4, we're going to add polynomials. The first thing that you want to do is to line up or group like terms. Now, you're going to line them up if you're using the vertical method, and you're going to group them if you're doing the horizontal method. And then you add the coefficients. Okay, so we're going to add, and the first method that I'm going to use is the vertical method. The way the vertical method works, we're going to write down our first polynomial, negative 12x cubed plus 10x squared minus 4x plus 15. All right, and the vertical method, which is my choice personally, and I am letting you know I don't care which method that you pick, I want you to use the one that works for you. And then we're going to line up 14x squared, excuse me, and we want to put it right under the 10x squared because they are like terms. Minus 15x, and then plus 9. And then draw your line, and we're going to add. Now, the cool thing about adding polynomials is we don't have to carry anything over. We can only combine like terms. So I'm going to start here at the left. And since there's nothing to add to the minus 12x cubed, I just bring that down into my answer. Next, I'm going to add the 10x squared and the 14x squared together, since they are like terms, which gives me 24x squared. And then I'm going to add the minus 4x and the minus 15x, which gives me minus 19x. And then the 15 plus 9 is 24. And there's my answer. It's long, but that is as simple as I can write it because I have combined all the like terms. All right, now let's do the horizontal method. And I'm going to, I want to use the whole screen, so I'm going to erase this. And in this one, I'm just going to go ahead and add on the second one, at plus 14x squared minus 15x plus 9. And here's the way that this one works. I look through my polynomial that I'm adding together, and I look for the highest power. And my highest power is the 3. And I don't see any other exponents of 3. So in my answer, I'm going to have a minus 12x cubed. All right? The next highest term is going to be an x squared. So I look for my x squared terms. And there's 10x squared, and here is a plus 14x squared. So I'm going to combine those together. And here I'm grouping them horizontally together. Then I notice I have, my next power would be a power of 1, so I have a minus 4x and a minus 15x. And I'm going to group those together. All right, and then finally I have a plus 15 and a plus 9, which would be plus 24. Oops, well, let me write it out. I was wanting to jump the gun there. Plus 15 plus 9. All right, so now let's write our answer. Negative 12x squared, or x cubed, doesn't have anything to combine with it, so we'll bring it down. Combining our 10x squared and 14x squared, we get 24x squared. Combining our minus 4x minus 15x, we get minus 19x. And adding 15 plus 9, we get 24. Now you'll notice as you compare this answer with the one with the vertical method, we have the same answer. We just used what is known as the horizontal method of solving. Okay, finally we're going to subtract polynomials, and you need to remember that subtraction means to add the opposite. And this is certainly a case where if you will do this, you'll make fewer errors. So when you subtract a polynomial, change each of the terms to its opposite, and then add the like terms. All right, so here we go. Using the vertical method, I'm going to write down my first polynomial, negative 4m cubed. Now I notice that I don't have m squared. So I can leave it simply blank, all right, and leave a kind of like a placeholder for it. And then I'll write my minus m and plus 9, and you'll see why here in a minute. If I want to, rather than just a space, I could add in a 0m squared. 0m squared is equal to 0, so it's not changing the value, but it is a placeholder in our polynomial. Then we're going to subtract 4m squared, and again I want to line up like terms. That's why I needed to leave a place, because I didn't have an m squared term in the first polynomial. And lining up again like terms, there we are. And I'm going to draw my line. All right, so here we go. We're going to, first of all, we're going to use the method of adding the opposite. So we're not going to subtract, but when we subtract, we have to add the opposite of 4m squared would be a negative 4m squared. The opposite of a plus 1m would be plus a negative 1m. And the opposite of minusing 12 would be adding 12. All right, and now we simply add them together. I don't have anything to add to the negative 4m cubed, so I'll bring that down. 0m squared plus a negative 4m squared would be a negative 4m squared. A minus 1m plus a minus 1m would be a minus 2m. And plus 9 plus 12 would be plus 21. And this would be our answer. All right. Using the horizontal method, I'm going to write it just what I have on the top. And let me go ahead and do that. Minus 4m cubed minus m plus 9. And then minus, we want to subtract the whole polynomial, 4m squared plus m minus 12. All right, so I'm going to use my rule to add the opposite. So opposite of 4m squared is negative 4m squared. The opposite of plus m is minus m. And the opposite of minus 12 is plus 12. And now I'm going to group them just like I did before. All right, so I don't have anything to group with the negative 4m cubed. I'll bring that down. I don't have anything to, let me circle that to know we've got that one done. And I don't have anything to add to the negative 4m squared, so I'll bring down the minus 4m squared. Now, I do have a negative 1m and a plus a negative 1m. And negative 1m plus negative 1m is minus 2m. And finally, I have a plus 9 and a plus 12, which would be plus 21. And again, I have the same answer using the horizontal method. All right, we're doing a worksheet, the 8-1 practice worksheet. So that is something that you will have to get from Mrs. Doris at school. And if you have any questions, please don't hesitate to bring them to Mrs. Doris. Thank you.